So we're going to do a couple more examples of those precipitation reactions. Here it says, write an equation for the precipitation reaction that occurs, if any, when solutions of ammonium chloride and iron 3 nitrate are mixed. So we need to write the formulas for these ionic compounds. So this is a little review of nomenclature for you. What color do I have going on here? Let's go with the chalk color. Here's ammonium chloride. Ammonium chloride, that's 2 ions. Yes, question?
When we have the test, for the ammonium chlorides, those boxes that we're supposed to memorize, are those all going to be on there? Or do we have to...
I am not going to give you the table of polyatomic ions, but I'm letting you have a 3x5 card. So you could photocopy it and shrink it down and stick it on your 3x5 card.
Okay.
Yeah. I really encourage you to memorize those. And one of my students from last semester got word that I was letting you have a 3x5 card, and I didn't let them have 3x5 cards last semester, and he's like, what? He wasn't real happy. But no, I played the world's smallest violin for him. Yeah. So no, I'm not going to give you the table of polyatomic ions. If you want to write them on your 3x5 card, that might be a good idea. Hint, hint, yes. Okay, so ammonium is NH4 plus, and that's something you look it up or you memorize it. Chloride is, we get that from the periodic table. Ions that end in "ide", most of them are single element ions, and we figure out their charge from the periodic table. So to combine those and make a compound, we've got NH4Cl. And it says it's a solution, so the state symbol will be AQ. The other one is iron 3 nitrate. Most ionic compounds have 2 words in their name. The first word is the first ion, the second word is the second ion. So iron 3 is Fe 3 plus. The Roman numeral 3 tells us the charge is 3 plus. Nitrate is a polyatomic ion, NO3 minus. So here we've got a plus 3 and a minus 1. There's various ways to think about this, but we need 1 iron and 3 nitrate ions so that the charges add up to 0. If this is not making sense to you, please come talk to me about it during lab. I'm pretty sure I can explain it to you. I've got like 10 different ways I can explain it to you, but I can't do all of those in class. But you can figure it out. You may just need one of the less conventional explanations. So please ask me for help. And that is aqueous. Probably going to run out of room here. So we've got 2 aqueous ionic compounds. What happens when an ionic compound dissolves in water is the ions separate. And so when we mix these 2 solutions, what we're looking for is what would happen when these ions switch partners. Would one of these make an insoluble compound is what we're looking for. So as the products, I'm just going to write these with their new partners. The exact order doesn't matter, but it's always the guy first, the positive ion first, and then the negative ion. So we're getting ammonium and nitrate, and then we're going to have Fe, forgot the charge, Fe 3 plus and Cl minus. So ammonium and nitrate are both a charge of 1, plus 1, minus 1, so those we just squish them together and they're good. Iron is plus 3, chloride is minus 1, and so that's going to be FeCl3, all squished over there on the side. In order for this to be an actual chemical reaction and not just stuff mixing, which would be a physical change, one of these compounds has to be insoluble in water. And how do we figure that out? We're going to look in the table, the solubility rules. I will give you that, okay? So I'm not going to scroll back to that, but if we look these up, we would see that compounds containing ammonium ions and compounds containing nitrate ions are always soluble, and there are no exceptions. So this one is aqueous. I didn't have enough space there, but I'll write it up here. If we look up and look for iron 3 and chloride, we find that chloride compounds are mostly soluble with some exceptions, and iron is one of the exceptions, I think. Now I'm second guessing myself. Does anybody have that table handy? Yes? No? Maybe so? Oh, it's really, really tiny. I know silver chloride. Because now that I think about it again, I think, no, it is soluble. I didn't bring my book.
Yeah, it's...
It's soluble?
No, it's insoluble. Or it's soluble, yeah.
Yeah, it's not one of the exceptions. Okay, thank you. It's always good to look. So chloride compounds are generally soluble. The exceptions, mercury, was it lead?
Silver.
And silver. Okay, iron's not an exception. So this compound is soluble. Is this a chemical reaction? Is this a precipitation reaction? No, it isn't. So the products are and are no reaction. Yeah. Okay? It's always fun when you get one of those on an exam because it's just a lot easier. Any questions? All that happens is that the ions mix and they all stay in solution.
So the NR means?
No reaction. N for no, R for reaction. Just, it's kind of early, right? 9:30. It's early in the morning. Write an equation for the precipitation reaction that occurs, if any, when solutions of potassium sulfate and strontium nitrate are mixed. So again, we have to figure out the formulas. So potassium is K plus, sulfate is SO4, 2 minus. So we put those two together, we get K2. I don't need parentheses, what am I doing? K2 SO4. It says it's a solution. We could look it up in the table, but we don't need to because we're told it's a solution. Strontium, that's kind of an odd one. We don't use that one a lot. SR, we find strontium in the periodic table. It's in group 2. It's got 2 plus charge. Nitrate, NO3 minus. So that's SR, NO3, 2. And that one's also aqueous. To predict products, we're going to swap partners. And we're going to put the potassium with the nitrate. And we're going to put the strontium with the sulfate. Now, we could actually check for solubility before we even write the formulas. So I do know that potassium nitrate is soluble. Sulfate compounds are generally, I'm blanking, helpful person with the table. We should print or do that on the board really big or something. Insoluble? Okay. So they looked it up for us, and that's insoluble. So that means we actually do need to finish this off. Bless you. Oh, thank you. Yeah, so sulfate compounds are mostly soluble, but strontium is an exception. So that means this compound is insoluble. So S stands for solid, not for soluble. And the potassium nitrate is aqueous. So then we need to finish this. So +1, -1, we just slap those guys together. And then we've got +2, -2. We can just push those together. SrSO4, solid. And then we need to balance the equation. So over here we've got 2 potassium ions. Over here we only have 1. So we need to put a 2 in front of the potassium nitrate. Remember, you can't change the formulas for the compounds. Over here we've got 1 sulfate. You can balance the sulfurs and the oxygens separately, but it's easier to do them as a unit. Because remember, we said that when an ionic compound dissolves, it forms 2 ions, and the polyatomic ion stays intact. It doesn't come apart. So here we have 1 sulfate ion, and here we've got 1 sulfate ion. 1 strontium, 1 strontium, 2 nitrates. 2 nitrates. There we go. Balanced chemical equation. Any questions? It's like some strange parlor trick or something, if you know what a parlor trick is. Been listening to too much Agatha Christie.